Again, try it again. Okay, recall the area of the square you saw earlier, which is also the square you have in your baggie, is 1 square unit. Complete each statement and explain your reasoning. So number 1 says, the area of the small triangle is blank square units. I know this because. Who thinks they know this one? Jack.
1/2 square units.
Okay, the area of the small triangle is 1/2 square units. I'm going to write my because down here because I don't have room up there. Because why? Who can answer that? How do we know that, Livy?
Because the square is 1 unit and 2 triangles is equal, 2 small triangles is equal to a square.
Okay, but let's talk about, it asked us about 1 triangle. So she is correct, and we're going to add that to our explanation at the end. But you use 2 small triangles equals a square. How can I say that, but I'm talking about 1 triangle?
Triangle?
No, we're talking about small triangles. Cooper?
One triangle takes half to fill it.
Fills up half of a square. You are correct. I'm just focusing on 1 small triangle. In your reasoning, you talked about 2. So you'll add this to your explanation, okay? Because 1 small triangle takes up the same amount of space as half of a square. And then we're going to add in parentheses what Livy said, 2 small triangles equal 1 square. So Livy, you said the same thing, just a different way. Since it was asking about 1 small triangle, I wanted to say something about 1 small triangle in my reasoning instead of pushing 2 of them together. Okay, so if you had something similar to that, your answer is probably okay, but see if there's anything you need to add to it to make it better. See if you can add anything on the board to make your explanation a little bit better. Okay, so now we can add to our reasoning that a small triangle is 1/2. Now that we have said it's 1/2 and explained why, now we can use the small triangle in our explanations. Number 2 said the area of the medium triangle is blank square units. I know this because. Nolan, what do you think?
I put it because 2
Hold on, what's your answer? Number 2, in the first blank. The area of the medium triangle is 1 square unit. I agree with that. Now, what is your reasoning?
I know this because these small triangles are 1 unit and they are the same size as
Okay.
a medium triangle.
Okay, so I'm just going to reword that a little bit. Because 2 small triangles take up the same amount of space, take up the same amount of space as 1 medium, and 1/2 plus 1/2 equals 1. I don't think we could get any more specific than that. So if you had something similar but maybe not as specific, go ahead and add to what you already had. Number 3, the area of the large triangle is blank square units. I know this. because. Jack?
2 square units because a small triangle equals 1/2 of a unit, and 4 small triangles have the same area as a big triangle.
Okay, so Jack's reasoning is 100% okay. I'm going to write this one on my whiteboard just so we can write different things because it depends how you looked at it. This is one where there's lots of correct answers. So Jack said the answer is 2. Jack said because a small triangle, I'm just going to abbreviate, is 1/2 and 4 small triangles, take up the same amount of space. As the medium triangle. Or sorry, the large triangle. Okay? Now, I'm going to underline pieces of that could be different. I'm not going to keep rewriting all the words, but I'm going to underline that. What could I change those words to? A blank and blank take up the same amount of space as the large triangle. What else could I have used? Did anybody use any other shapes? Jude?
I didn't, but you could use 2 medium.
But we don't have 2 medium. We do have 4 small. Hold on, so let's go with that. In place of, because we only have 1 medium, what could we replace your other medium with?
A square?
Jalen? 2 small. You could have said that 2 small and 1 medium triangle take up the same amount of space. Our math would have been a little bit different. This one would be 1/2 plus 1/2 plus 1 equals 2. I didn't put our math up here. Our math up here would have been 1/2 plus 1/2 plus 1/2 plus 1/2 equals 2. May I have another one that would work? There's one more. Cooper?
2 small triangles plus a square.
Good job. 2 small triangles and a square. 2 small triangles and a square. And that math would have been the same. Because that one would have been, like there's our square. That's not right. It's possible. I just have to think. Oh, the square goes this way. Right? Yeah. There we go. That would also make the large triangle. Okay, so any of those are right. Instead of A, 2 small triangles and 1 medium triangle take up the same amount of space as the large triangle. Or 2 small triangles and a square take up the same amount of space as the large triangle. All of those are possibilities. You don't have to have them all, just one of them. Okay, turn the page. You didn't have to do number 1 for homework, but we're going to do it together right now. So to the practice problem. So I believe we are on page 19. There's a problem up at the top that I didn't give you for homework last night, but we're going to do it together right now. Number 1. Lesson 2 practice problems. The diagonal of a rectangle is shown. Okay, so they drew the diagonal line through the center of that rectangle. Part A says decompose the rectangle along the diagonal and recompose the 2 pieces to make a different shape. What does that mean? Decompose it along the diagonal and recompose it. We would probably use a different word there. Sadie?
So you take a part of the rectangle and then you build it again a different way.
Yeah, you rearrange it and build it a different way. So everybody think about, because you can't obviously pull the paper apart, think about pulling those two apart. So what two shapes do you have? Two right triangles. I want you to rearrange it somewhere else on the grid. It doesn't matter where. Try and keep the size the same. So pay attention to the dimensions. The bottom of your triangle is 2. The other side of your triangle, the longer side of your triangle, is 3. So see if you can rearrange it somewhere else and make a new shape. This is kind of what we did on our desk yesterday, a new shape. It can't be a new rectangle or a rectangle turned.
But just those two triangles?
Yep, just those two triangles is all you have to work with.
It has to be like an actual shape.
Has to be a real shape, a regular shape. It can't be a rectangle. You're taking those two right triangles and making them into a new shape. I suggest by just taking one of them, drawing one of them, and then just thinking about, okay, where could I put the other one to create a new shape? Okay, so to help you get started if you're stuck, I'm just going to take one, oops, not that. I'm going to take one of them and draw it right here. Okay, there's one of them, so I've taken care of one of them. Now I have to take the other one, put it somewhere. Has to be touching. You just have to be touching. There we go. It has to create a new shape. That's not a new shape. That's the same shape in a new spot. Dane, where could I take that?
You could put the other triangle on the other side,
What do you mean?
the bottom.
On the bottom of it? So Dane is saying if I take the other triangle and put it here, like that, what kind of shape did I just create? A parallelogram. Who had a different one? Let's draw another one because there's others. And we have lots of room. Okay, there's my original. I took one of them and put it there. Where else could I put the other one, Stella?
Like to the left and then.
To the left of it, if I left it like either way, I'm going to do this one twice. If I turn it, if I rotate it, what shape do I create? A bigger triangle. I'm going to do one more down here. If I don't rotate it, it would look like that, and I have a different type of parallelogram. So from two right triangles, I can rearrange them into lots of different shapes. I can take two right triangles and rearrange them into a rectangle, into a larger triangle, into two different parallelograms. Go ahead and copy at least two of those down. Everybody should have one. Copy at least two of them. Then we're going to go on to number 2. Before we get to number 2, I will say on the worksheet that I've graded, so far you've done really good showing work for the most part. If you did not show work on that back problem, you lost points, okay, because it said show all work. But again, most of you guys did really good showing work on that worksheet that I collected. If you didn't, I took off a point and I told you why I took off a point. On number 2, you should have some work. Okay, on number 2, you should have some work. If you do not, you need to get it filled in when we go over it. For this one, I told you the question says the area of the square is 1 square unit. 2 small triangles can be put together to make a square or to make a medium triangle. So this is the activity we did yesterday. We already discovered that I could take apart the square into 2 small triangles, and then I could use 2 small triangles to make my medium triangle. It says, which figure also has an area of 1.5 square units? Select all that apply. Who thinks they know what I want to see on letter A? Let me move this over. What do you think, Soph?
You label 1/2 of each small triangle.
Yeah, I want you to show me that, hey, I know all of these are 1/2. Okay, then what?
You times them.
Okay, what do you mean times them together? What math did you do on your paper?
I multiplied
What did you multiply?
all the 1/2.
Like, read me what you have on your paper.
1/2 times 1/2 times 1/2.
Okay, so that is incorrect. So she said 1/2 times 1/2 times 1/2. But we can multiply. Who can fix her problem with 1/2s? Jalen? You would add them together. So let's write this because we need the total area. So we would just add those together. 1/2 plus 1/2 plus 1/2, which is 1 and 1/2. Or, I want everybody to add this, or what multiplication problem could I use here, Nolan? Why can I use 3 times 1/2? Yeah, because it's repeated addition. So that's why I wanted Sophie to elaborate, because you could use a multiplication problem here, but it would be 3 times 1/2 because I'm adding 1/2 3 times. Okay, that would also give us 1.5. So is this one of my answers? Yes, because the total area, I'm just going to circle all of mine. The total area was 1 and 1/2. For B, Sophia, can you help me with my work there?
Well, we could put 1/2 in each triangle.
Okay, because we know.
Put like a 1 in between the two triangles that make a square.
Okay, so Sophia's saying I could label it like that, or I could have noticed, hey, that's a square, and just put a 1 in the center. Do you have to do all of it like I did? No, but would both of those individually be okay? Yes, okay. Now, Jude, let's pretend we left it all as triangles. What would my work out to the side be?
For what? That?
For B.
You would add 1/2 plus 1/2 plus 1/2.
Which is
1 and 1/2.
1 and 1/2. Good job. Or what multiplication problem could I put out there?
3 times 1/2.
Yes, 3 times 1/2. Good job. Okay, so that is also one of our answers, correct? C, Carter. What work should I show for C?
1/2 each triangle.
I what?
1/2.
Okay, not in both of them. The area of what kind of triangle is 1/2? The small one. Are these both small triangles? Nope. So which one do I label 1/2? The top one is 1/2. That bottom triangle is what type of triangle, Haley?
Medium.
A medium triangle. What is the area of the medium triangle? 1. Or this is one, if you're going with like Sophia's thought process over here on the square, you could have decomposed it into 2 small ones if you wanted, or left it as is. I'm going to leave it as is and say that this is 1. What's my math that should be out to the side, Chase? 1/2 plus 1 is what? 1 and 1/2. So that again is another possible answer. Last one. Harper, what am I labeling?
The square and the 2 triangles.
Okay, what am I labeling them with?
1/2, 1 and 1/2.
So the triangles are small triangles, so they are each 1/2. 1, 1/2. Ethan, what work should I have out to the side?
1 plus 1/2 plus 1/2.
Okay, and what is 1 plus 1/2 plus 1/2? 2. So is that one of my possible answers? It is not. We're also going to do number 3 on the next page. I want you to look over at number 3. This was not your homework last night. We're doing it right now. I don't want you to mark anything yet. I want you to read through the whole problem and in your head come up with which one you think is the answer. So you're reading through number 3. Don't mark it yet, just in case you're wrong. And then come up with what do you think the answer is. Okay, so Priya, that is a name, she shows up a lot in this book. Priya, What essentially is she doing? Sadie, what's she doing?
She's making a new shape of her original shape.
Yeah, she had a square. She cut it into smaller squares and rearranged it into this figure over here. And the question says, how does the area of her new shape compare to the area of the old shape? Is the new figure bigger? Do they have the same area? Is the original one bigger? Or we don't have enough information? Reese, what do you think?
B. The two figures have the same area.
Okay, do you guys agree? Okay, Livy's disagreeing. Why do you disagree, Liv?
Because I think it's D. Because you can't measure the area if you don't know what the outside of your thing actually is.
Okay, so to give you an example, I'm going to use Sophie as an example. You can stay sitting. I won't really do this because I don't like blood. If I took Sophie, now her face looks a little scared. If I took Sophie and I chopped her in half at her waist, and then I put her feet on top of her head, I just decomposed her, I chopped her in half, and I rearranged her. Okay, now her feet, like her waist is up high, her feet are right here above her head, and her belly button is on the ground. Okay? Does she still take up the same amount of space? Yes. Does she look different? Yes. That's what this problem is. It's decomposed without all the blood, okay, and rearranged. Even though it looks different, it does take up the same amount of space. Why is that hard for us to visualize? Why is that hard for us to visualize, Jack?
Because it looks different.
Yeah, because it looks different. And another example, if two people weigh the same, okay, if they have the same weight, do they necessarily look the same? No. Could they be the same height and still weigh different? Yeah, because there's lots of factors that go into that. Like muscle weighs more than fat, right? So muscle weighs more. So even if they look about the same, their weights could be completely different. This one looks completely different, but the amount of space they take up is exactly the same. So this one is B. So go ahead and circle B. But then we're going to write an explanation up here at the top. Okay? You have a little bit more space than me, so you can just go up here, like next to this blue box is where you guys can write your explanation, like the blue square. So I'm going to put she decomposed and rearranged her original what did they call it? Did they call it square or figure? Square. Her original square. The new figure looks different. Oops. Figure looks different, but takes up the same amount of space. And that's just kind of like the rectangle that we did on number 1. When I decomposed that rectangle into 2 right triangles and then rearranged it, that original rectangle and the shapes we drew had the same area. They still took up the same amount of space because they were both composed of 2 right triangles. Once you have all of that written down, I want you to go down and read number 4. And try and answer number 4. Go down and read number 4 and try and answer number 4. Is anybody still copying this? No? Okay. What shape are we talking about? A rectangle. Jude, what does it tell me about my rectangle?
The length is 13 meters.
Okay, it tells me the length of my playground. What else does it tell me, Jalen?
The total is 78 meters.
The whole area. Okay. Hold on.
Do I have to take my stuff?
Where are you going?
Band.
Yes, you will take all of your stuff with you. But also, we're finishing this problem, and then we're going to discuss that. You know what that is, don't you? Okay. Okay, so we know it's a rectangle. They give me the area, and they give me the length. What do we know about area of a rectangle, Nolan?
One side is longer than the other.
Okay, one side is up. What do we, when we hear area of a rectangle, what should pop into your head, Harper? A equals length times width. I still want us to think that. So for this problem, I want you to write A equals L times W somewhere, even if you already know the answer. When we have a formula, we rewrite the formula, then what do we do? Substitute what we know. We know that area is what? 78. We know that the length is 13. Do we know W? No. So we're really trying to figure out 13 times what number equals 78. What math could I do here? Division. What would my division problem be? 78 divided by 13. If you tried to set this up using long division, why does that not really help you much? It goes into it a single digit number of times, which really means it's like a guess and check. Okay? Who found it? Jack? 6. Okay? It does go in 6 times, which means that W equals 6. 6 what, Haley? No?
Meters.
Why is it just meters and not squared, Haley? Look at what it's representing. It's representing a width. Width. Would you say I'm 5 squared feet tall? Or 5 feet squared tall? No, if you're talking about a distance, it's just the standard unit, just the unit all by itself, not squared, not cubed. Okay, we're going to stop there in the book today. Go ahead and close your book. Okay. Work on, you log into your computer. Do you have it with you? Okay, you work on getting logged in while I work on pulling this up. Hey guys, we're not done yet. I just asked you to close your book. Okay, you don't have homework tonight, but I am giving you your first IXL assignment. Because remember, you either have a weekly worksheet or an IXL skill. This week you had a weekly worksheet, so next week you have an IXL skill. I will be giving you this paper in just a second. Just refreshing your memories. You won't have time to get logged in and actually get going on it, okay? I'm just having Ella get it out because she's not even added to my Google Classroom yet. Okay, IXL, same as last year, but I'm still going to go over to make sure everybody hears this. I will give you 1 or 2 skills per week to work on. I do not know. Yeah, probably. Okay, this week I'm only giving you 1 skill in big bold print. I put 6th grade G1, because when you first log into IXL, it will probably still be on 5th grade. This week, I also wrote in what skill it is, add and subtract decimals, because if you don't notice you're in 5th grade, but you go to skill G1, it will not be add and subtract decimals. What should be on the bottom of this paper when you turn it in? Work. You must get to a SMART score. With me, Nolan? Of a SMART score of 75 or higher. Show all work. When you are finished, record the score that you got to. If you want to go higher than 75, you can, but you do not have to. There's no extra credit for going higher. But again, if you just start working and keep going, that's fine. If you don't get to 75, let's say you only get to 68 by Friday, your score will just be a 6.8 out of 7.5. Okay, it's very similar to last year. Questions over that? When is this due? Says it right here, due 9/2, which is next Friday. If you get it done today in study hall and you want to come turn it in, you can. If you get it done on Tuesday, can you turn it in on Tuesday? Yep. Yes, at any point throughout the week, if you get it done, you may come turn it in. Got it? Okay.